Good evening, everyone. Nice to see you all here to this evening gathering together. Today, I'd like to talk about building production AI agents from chaos to clarity. I think I see a few familiar faces in the previous talk, but this is a bit of a updated slide. And my name is Darren. I'm the technical architect in AgentForward. I've been in software engineering now 17 years now, building backend systems to modern agent architectures right now. I'm currently building an AI agent platform at AgentForward in Tokyo, August, to help our financial AI applications features. And I was from cloud, being a cloud architect, and then now doing AI. I'm a believer in learning through failure, iteration, and then having the clarity to move forward after that. Nice to meet you. So what is this presentation about? To start off, it is sharing what actually worked for us, and what to avoid, sharing our pitfalls, the anti-patterns we discovered, and our initial objectives on the journey we undertook. And what it isn't, we're not trying to build something to compete like OpenAI. Our tool isn't for public use. We build it to help our enterprise company to scale, to build AI agents really fast, effective, able to go to production, and being compliant with everything within the company. And it's not a definitive framework comparison. I don't know if the long list of frameworks, libraries, which one is the best. We've tried a few. We know what worked for us. That's what we're trying to share. And of course, it's not a one-size-fits-all approach. We're just sharing what we have learned. And without further ado, let's take a look at the agenda. First, we'll talk about context engineering over prompt engineering. What is agentic agents versus workflow agents? MCP, how it has enabled us to scale, connect all the different systems, platforms we have within the company, and build persistent AI agents. And then we talk about sub-agent architecture, which is actually really important. There's a lot of times we think about the most complex agents, but actually the most effective ones are actually sub-agents. So let's talk about that. And the last thing is designing memory systems for intelligent agents, because without memory, they are very vanilla. Yeah. So a brief introduction, what is an AI agent? Research web, something like a system where LLM dynamically decides the control flow of an application. That's a very generic term, but the distinction is that if you look at the bottom, there's a spectrum of what an AI agent is. You can go from a really simple classification, problem solving, to recommendation, to multi-step automation assistance, to autonomously running research, on the frontier of AGI that everyone talks about, having the capability to replace humans directly. So that's what I think AI agent is. And let's talk about context engineering first, trying to define it. Andre Kapati coined this, I think, last year. And a lot of industry people agree. Context engineering is the delicate art and science of filling the context window with just the right information for the next step. So I think we view this as the LM just being a CPU, or the context window is the memory, and it needs to select, compress, and structure in order to be effective. Let's move along. So what's actually in the context window today? So you're given a specific context window, like Opus has 200K, Sonnet has 1 million. How do you fill it in? What do you fill it in? There are system prompts, there's tool definitions, there's memory calls, session data, retrieve knowledge, histories. So at the bottom is the key. So the creativity is in how you fill each segment and how much, what do you fill it in, and optimize it for the next step. And there's a few patterns that we see on how do we fill this context window. This is the list. Context hydration, where you fill it with the essential data before the conversation actually starts. So if you're a generic agent, there's not much, but if it's a personal agent, what the agent has to know about the user, has to know about the system. If it's about monitoring, what's the current data of the system? If it's a stock keeping, what's the current stock? Is it out of stock? Is it low in stock? So those are all the essential information that you put in before the agent actually starts having conversations. Lazy loading. So yeah, you can't load it all. We have a limit on the context window. So you got to decide, what do I lazy load? What do I preload? And yeah, that's the third thing, preloading it. The fourth one is context injection. So we have different slots that comes in at the right time, and you want to inject them when the conversation progresses to a state where that condition has been reached. Hot swapping, basically you have you're swapping in information in as the conversation progresses, like a username. So hi username, go in, and then the username gets swapped with the user for the session. Yeah, that's a very simple one, but you get the idea. Budgeting the tokens, you can't just have a big pool and just put everything in and hope it doesn't get filled up. You have to budget it, how much can be filled for each category. And context compression. Yeah, since we have a limit, as the conversation gets longer, we have to compress it. But how do we compress it? How much? What's the strategy? Do you truncate? Do you compact? All of those strategies comes in. And then context eviction. Not all has to stay in there and wait for context compression. Some can just be in a single conversation round, they get evicted. Some stays all the way. Some gets evicted based on condition and triggers. Yeah. And next I want to talk about DAOs, basically. So when you build AI agents, this was what really important for us. We needed to make sure we have all these DAOs for the agent. And on the right side, you can see there's a context window DAO. So every agent had a different requirement, how much context window they need. Because as we all know, larger context doesn't mean it's better. Think of the context problem and all that. Temperature, the model, the guardrail strictness. Some needs very strict guardrails, some doesn't. Yeah, and then at the bottom, sometimes some kind of configurations around what's the database, what's the email. These are the tools that we build once and attach to the agent. On the left side is the configurable parameters. So that's a summary list of what we have today. The prompts, the guardrails, the 2-axis controls, and we even build webhooks and triggers. And then a thinking mode, do you turn it on? Do you turn it off? Do you need the thinking? Retry, fallback, bread limiting, etc. Yeah, then let's talk about agentic. Is not automated. The critical difference here, I think on the left is the workflow agent that we can build today. There's nothing wrong with it, but we just need to know about the limitations on what it can or cannot do. So you can go through that and build a tree branch from conditions up to conditions, A to B to C. But we, as programmers, as software engineers, we all know there's a limit to how far we can go with this. If it goes too far, it becomes really hard to debug, to build, to test. And yeah, that's when it gets out of control. So the agentic agent that we talk about is on the right side. Treat it like an intern who joins a team from day one. You don't actually tell him, just do this. I tell you to do this, just do it. On the contrary, you actually train him, you talk to him, you share your knowledge, you guide him, you give him the tools, and then you taught him the principles and approaches. And then the intern handles the situations by himself. He's being taught to think and adapt, and he might make mistakes. And that's where you correct him from time to time, or maybe there's a documentation error that he made those mistakes. So that's the agentic approach. Yeah. And this is sort of the summary of what happens when you truly try to build an agentic agent. It becomes the center where you surround it with tools, knowledge, memory, resources, and even sub-agents that does very atomic things. And then you decide on the 4 corners, what to use them for, how to use them, which tool does it use, and when to use it. Those are all the trainings. So at the bottom, there's a summary where building the tools and everything that surrounds it is actually just a short-term project. You build it once, you make it work, it's predictable, done. But building the agent themselves is a long-term commitment because models gets changed over time, capabilities and all that. And yeah, that's the long-term one. MCV has been one of the, I would say, pillars that enables us to accelerate so fast, because it has been really easy to lean on it and connect all the systems, all the tools, all the APIs that we have, and just build really fast and then strap them on our agents. I'm going to give an example here, a really simple one. So we built a custom wrapper. We basically adjust the config file, and with just this almost 10 lines of definitions, we have the API parameters and we have the description. That's all we need. And we have an API tool that's being wrapped as an MCP tool for the agent. So there's no code. It takes a minute and then developer immediately tests it. Of course, this is not the full interface. We built integration with our internal gateways, internal API platforms. So authentication, security, and all that's been taken care of. So this really enabled us to scale really quickly because all companies have APIs today. But if you want to build an agent and you want to give them a new requirement list, yeah, that's going to take a while. But the crude methods are there. So we don't actually have to start from zero to build AI agents. We can rebuild. We can build by using what we already have. Next, I want to talk about sub-agents. So one of the things that we had success with is building sub-agents. From early on, we know that building a big agent with a lot of capabilities is not the way to go. It's really hard to test. They reach a certain threshold point where they start hallucinating, where they start not following the instructions. So finding that function layer and carve it out and build a sub-agent and then test it based on those narrow scope and tasks and skills is much more effective. Yeah, so don't build a mega agent. Yeah, these are the symptoms and the pitfalls where your tools just get much more over time and your system prompts just grows, and then there's no too much skills, too much tasks, too much things the agent needs to know for a mega one, and it's going to break, it's fragile, and it's almost impossible to test. So the benefits of sub-agents are plenty. You have a much clearer tool selection. The context is much more focused. You test each in isolation, and there's graceful degradation. You improve one specialist at a time. You select the right model for the task. Don't use all the same models for everything. That's why we have the choices of like Haiku, Sonnet, Opus, and all the different variations. So sub-agents doesn't need a really powerful large language model at times. Clear ownership and boundaries. Yeah. This is an example. Basically, we have a finance agent, a sales agent, and an HR agent here. They are specialized to do one thing really good. And then, yeah, their key characteristics is that they're stateless. They don't have sessions. We don't have to retain the conversation history. So they are highly cached, which is also good because the tokens are much, much cheaper if you cache them. They are singleton, performance optimized, and reusable. So this is what I think has been proven to work, even with Claude Code. The main agent as an orchestrator who understands the intent, drives the conversations, and then synthesizes the response as it delegates the task to different sub-agents. Next thing I want to talk about is memory systems, which is also very important because an LM doesn't do much without memories. So there's a few types of memories that we have identified. The first one is short-term. When you start a conversation, as you talk to the agent might need to save some key information as the conversation progresses. That's a short-term memory. So you come in, you tell them and talk about, oh, I need you to solve this problem, right? After 10 rounds of talking, he still remembers what was the problem. But you also need long-term memory. This is where it goes across sessions. It's persistent storage processors. Episodic memory is where you don't want to build an agent today that you test and it works, but then that's what it does for the next 10 months. You want it to also be able to learn, be corrected, and store it in episodic memory, and then it will not repeat the same mistake. So strapping this memory will allow that self-learning loop to happen with your agent. Semantic memory is all the factual knowledge that you want him to have and to search for it to answer any questions that the user might ask. Procedural memory is the SOP basically. To complete a task, there are certain steps or SOP, but if you put everything in the system context, that's just going to hallucinate and it's going to take up all the window. So allowing a procedural memory to be accessed by the agent when it is asked to complete a task will ensure that he only pokes the SOP manual when he needs that. Yeah. So what is AgentForward currently cooking? We plan to release around 25 agents this half. We want to make our products AI native. New products are being built with AI centric from the start, not as an afterthought. We're also building internal platforms called Astra to enable all our employees and departments, divisions to build AI agents to help their productivity. And the company goal was to double the productivity by 2028. Some examples here. We have accounting and finance. Classifying assets has been a pain point in the backend office systems for financial. So this is where the sub-agent comes in with some OCR, understands what the image is, and give the right asset classification. But we also strap all the data that each company office has with us in the past and train that with the agent. So if an office says their MacBooks are service life 5 years and MacBook Air is 4 years, right? So this data is going to be able to identify that. And then even if the first time they do that, it's going to go into the memory and the next one will be accurate after that. There's also engineering, SRE, operations, compliance. These are all the internal agents initiatives that we're driving to increase productivity. Yeah. So the summary and takeaways, invest in context engineering. It's really important. Leverage the open protocol so that you get started really quick. Measure in production. Make sure you know what the agent is doing, because as we saw just now with agentic agent, it makes those decisions himself. So what are those decisions he made in every single interaction? So being able to observe that in production is really important before things get out of hand. And architect for memory and modularity. Yeah, this is just a snapshot of our agent builder UI. So we give this to all our engineers who build AI agents, so they don't have to really do too much to know exactly what the agent is doing. They can change the model immediately if they want to. So we support Claude, OpenAI, Gemini. Which one works? Give them the tool and they will find out. Yeah. So that's it from me. Let's stay connected if you want. That's my LinkedIn QR code. And I'll post the deck in the profile tomorrow. Thank you.